All right, so this will be 8.6, and it deals with polynomial inequalities. All right, so let me refresh you on a few things on these about whether you're going to use less than, greater than, or less than equals and greater than or equals. So on these, if you have equals under those inequalities, if they got equals under them, you got to use the brackets on your answers. If it's just greater than or less than, you got to use parentheses on those answers. Sort of similar to interval notation on these, because these answers will want me to put them in interval notation. So I just wanted to refresh you on that. So the steps to solving these inequalities. All right, so the first thing you want to do, just like on any of these, you want to get everything set equal to 0. So get the polynomial equal to 0. All right, once we got the inequality equal to 0, you can solve by factoring. Or you can use the quad formula. So since we're dealing with quadratic polynomials, you can use the factoring or the quad formula either way to solve these. So here's where you start getting into the inequality part of this. Once you have these solved, I'm going to set up a not a timeline, but a number line. Set up a number line using the solutions. So that'll be a little number line here, and I'll have my two answers. All right, so you're going to set up a number line using the solutions. So once you get this number line set up, we got to figure out where to shade it to get the answers. So test a number in the different parts of your number line to see if true or false. If true, we shade that section. And then y'all, the last thing, right answer in interval notation. Now, a few things on this. If you only get a single answer when working this, so if we only get one repeating answer, then that is the only number we exclude from the domain. So say I factored this and I got x equals 2 and another x equals 2. When I solve that, I would only exclude the one number from my domain. But all these but one should give you 2 answers, okay? All right, then there's one more star. If the polynomial cannot be factored, so if the polynomial cannot be factored, then it is a no solution. And y'all, a lot of times for no solutions, in this section, they use the little 0 with the line through it. So let me give y'all a second to do that, then I'm going to show you the 2 styles of answers you'll get.
Sir, can you come down a little bit?
Oh, is it not now? Can y'all not see a number line?
Now we can. Yeah.
Okay, yeah. So I'm going to show you the 2 types of answers you get. One answer, they're going to shade in between the A and the B. Or, let's draw another number line. It's going to shade to the outsides. Okay, so if you get the top, your answers will either be a set of parentheses, or if you got the equals, it'll be brackets. So if it shades in the middle, you'll either have a set of parentheses or brackets with your interval in it. If you got this style right here, these answers will go from negative infinity to the A, and then you'll union them from the B to a positive infinity. Or this side could look like a negative infinity to A with a bracket, and then union a bracket from B to positive infinity. So it depends on whether you got equals in here to use the brackets, okay? But this is the 2 types of answers you'll get on all these that got the 2 different answers instead of the 1 repeating answer. All right, so let's play with these. They're not bad as all those instructions I wrote. They'll say solve the following inequality. So y'all, the first one is going to be parentheses x minus 3 times parentheses x plus 4 is all less than 0. So this one is starting at the point where you had it factored. They've already factored this one, so we're just going to finish it out since we got a 0 over here. Now the next one will actually have to do all the factoring, okay? But this one, they sort of was nice and already factored it. So at that point, to finish solving it, we would set both of these equal to 0 and solve them. So the first one, you would add a 3 to both sides. And I get x equals 3. Second one, I would subtract 4 from both sides and I get x equals a negative 4. So I'm going to set up my timeline, my number line now. Let's see, the one that would be first would be the negative 4, and then 3 would be on the right. So y'all, let me say this. All of these will end up with one of these two styles. When you got two answers like this, it's either going to shade in the middle or it's going to shade on the outsides. So the easiest number that I use to check these is 0. So I'm going to test 0, which is right in the middle of the negative 4 and 3. If 0 makes this true, I'm going to shade that section. These sections will be blank. When I test 0, if that's false, I'll leave that answer not shaded and I will shade the outsides. So I can test one number to figure out how to shade this. And it just depends on where my 0 is. Now, you can use any number you want to test this, but I use 0 because it's the easiest one to work. So if I'm going to test 0, I would put 0 in for these problems. I would do 0 minus 3 times 0 plus 4 has to be less than 0. So let's see what we get. This gives me a negative 3 times a positive 4 has to be less than 0. And let's see, when you multiply negative 3 times 4, you get a negative 12 less than 0. So true or false? That would definitely be true. So since this is true, we're going to shade the section that 0 was located. So I'll write that again. Let me make my number line. I got a negative 4 here and a 3 here. Since I know 0 is in between negative 4 and 3 and it made that true, I would come in and shade between my negative 4 and 3. Now all you got to do is write the answer in interval notation. Look up here, there's not an equals under that, so we got to use parentheses on that. And remember, up here, when we had that style, our answers is going to look like one of these two, right? Since we didn't have the equals under that, it's going to look like the parentheses. So your two numbers and then parentheses. So I would have parentheses. My first number is a negative 4. And then it goes all the way to a positive 3. And I use parentheses. This right here is what MATLAB wants, is our interval notation on that. So what that means is any number I pick in between that negative 4 and 3 would make this a true equation. Any number outside of that would make that false. So you could put like a 4. 4 minus 3 is 1. 4 plus 4 is 8. 8 times 1 is 8. And 8 is not less than 0. So that's why this side didn't get shaded. And you can do that to that side left of that negative 4. So the trick is solve it, figure out your number line, test the 0, and then shade them. All right, so we're going to have to do another one of those. All right, x squared minus 13x plus 22 is greater than 0. All right, so once again, there's no equals under this, so we'll be using parentheses on all the answers. First thing you got to do is factor this. So I'm going to break out my parentheses. And at that point, I'll just set it equal to 0. All right, let's see. We got an x squared, so that'll be an x and an x. That last number is a positive. So anytime the last number is positive, both of these factors will have the same sign as the middle. So both of these will be negative. Now I need factors of 22 that'll add to get 13. So you got 1 times 22 and what else? 2 times 11. And the ones that equal 13 are 2 and 11. So I bring them down. All right, so now it's at the point where they gave me that problem number 1. I got 2 parentheses equal to 0. So set both of these equal to 0 and solve this. So the first one I'm going to add 2 to both sides. I get x equals 2. Second one, I'll add 11 to both sides. And I get x equals 11. So my answers are 2 and 11. So I'm going to make my number line. Let's see, 2 comes first. And then my 11 will come second. Now, I'm still going to test 0, but notice 0 is inside this first section over here. Because this is 2 to 11 here, and then anything bigger than 11 will be to the right. So 0's in this section. So check this out. If it's true for 0, I'll shade the first section, and then I skip this middle, and I will shade the last section. Anytime the first section's shaded, the last section's automatically shaded. If I get a false answer when I test 0, then I won't shade that area. I'll shade the middle only. So you either shade the 2 outside sections or you only shade the middle, depending on what you get on these 0s, okay? So let's put a 0 in here. I'll have 0 squared minus 13 times 0 plus 22 has to be greater than 0. So y'all watch this. 0 squared is 0. Minus 13 times 0 is 0. Plus 22 has to be greater than 0. And look, that's going to be true, right? Because 22 greater than 0 is true. So since that's true, I shade the section where 0 was located. And then the last section gets shaded. Also. So anytime you shade this first little section here, so let's bring that down. I had what, 2 and 11. Anytime you shade this section, you gotta automatically shade that last section. These two always go together. The one I had earlier shaded only the middle, so I didn't have to worry about anything else. You can't have 2 sections in a row be shaded, okay? All right, there was no equals under this, so I will use parentheses. And I showed you a while ago that if the outside edges were shaded, you always started at negative infinity on this side. So from negative infinity, you go until you hit the 2. Remember, it's curvy parentheses. And then you skip this whole section in the middle. And then you start back up here at the 11. And you go towards positive infinity. So this right here is the answer that your math lab wants. So it's not too bad. You just got to get these number lines set up with the right answers and then just figure out where to shade it, okay? Now, I only used a 0 to check, but you can use any number you want to, and you can check any section. Hell, you can check all 3 sections with numbers if you want to, okay? All right, let's try this third one. I got an x squared minus 4x minus 22 is greater than or equal to x minus 8. So you look at this one and you notice there's not a 0 over here, so this side needs to be 0. So what I'm going to do to get a 0 here, I'm going to subtract the x from both sides, and I'm going to add an 8 to both sides. Right? So since I didn't have a 0 here, you had to add the opposite of the x's to both sides, and then the opposite of the negative 8 to both sides. So what's over here, you got your x squared. A negative 4x, and then a negative x will give me a negative 5x over here. Negative 22 plus 8 would be a negative 14. All of this is greater than or equal to 0 now. So basically, if you want something to move, you change its sign. Okay, that x was positive, it become negative. The 8 was negative, it become positive. So now this is what we're worried about solving. So let me bring down my parentheses. And at this point, I'll just set it equal to 0. I do know at the end when I write my intervals, since this one has the equal sign under that, I will use the brackets this time, okay? All right, y'all, here we go. We got an x squared, which is an x and an x. This 14 is negative this time. Anytime the last sign's negative, one will be positive, one will be negative. All right, so 14 can be 1 times 14. What else? 2 times 7. Now, since the 14's got a minus in front of it, I want two numbers that subtract and get a 5. So that'll be the 7 and the 2. Remember, the larger number has the same sign as the middle. So since the middle's negative, the 7 has to be the negative and the 2 be the positive. All right, at that point, set both of them factors equal to 0. If you notice, at this point, all I'm doing is changing my signs, right? This 2 is positive, so I would subtract 2. And I would get a negative 2 for that one. This one is negative 7, so I would add 7 and get x is a positive 7. So I got my two numbers, so let me make up my number line. All right, let's see, who's first? Negative 2 would be first, and then 7 would come after. This time when I look, my 0 is in between the negative 2 and the 7. So I'm going to test my 0 right there in the middle. All right, so go back to your equation. Now, you can use the original equation if you want to, or you can use the new equation we came up with when we got it equal to 0. I'm going to use the new equation because it's smaller. So I'm going to do 0 squared minus 5 times 0 minus 14 has to be greater than or equal to 0. And the reason I'm using zeros is because usually the x squared and the x term cancel, and you're just looking at that last number. So 0 squared is 0, 5 times 0 is 0. So you get a negative 14 greater than or equal to 0. That is false. So we don't shade the section with the 0. So we don't shade the section with the 0. So since I don't shade the section with the 0, I got to shade the first section and the last section. Okay, because remember, it's always got to be the middle shades or the outside shades. So, remember, when you had these styles here, you started at negative infinity until you hit the first number, which was -2. Since I got an equals under that, I'm going to use a bracket. And in union that from the second number, which is a 7, and it goes until it hits a positive infinity. So basically, the shadings are telling me what to do with these intervals down here. And I'll tell you where I get people the most is on brackets. Are they using parentheses or are they using the actual brackets on those, okay? All right, y'all, let's go to number, what's next? Number 4. Four has x squared greater than 64. So many ways you can solve this. You can get everything on one side equal to 0. You can factor it or hit it with the quad formula. This one you could actually square root both sides if you wanted to. But what I'm going to do is I'm going to do them like I've been doing them. So on this side I need a 0. So I'm going to subtract 64 from both sides. So this side will give me x squared minus 64 greater than 0. So this one don't have the equals, so I'll use parentheses for all the answers. Right, y'all, I'm going to factor that and set it equal to 0 when I do that. This is the difference of perfect squares. So that'll be an x and an x. The last number's negative, so one's positive and one's negative. There's not a number in the middle, so you would treat it like a 0. So what I would want at this point would be factors of 64. So let me get some of these. 4 and 16. 5 don't go, 6 don't go, 7 don't go, and then what else? 8 and 8. Since there's not an x in the middle, it's like a 0. So one of these sets of factors will subtract and give me a 0, and that's going to be my 8 and 8. So I get an x plus 8 and an x minus 8. But y'all, this is the difference of perfect squares. So y'all automatically, all you got to do is take a square root of 64 to get those 8s, okay? All right, set these equal to 0. So I sort of like this section because it gets you sharp back on that factoring, because all these have to be solved by factoring if you want to, okay? So that, and I subtracted 8 and got a negative 8. This one I'll add 8 and get x is a positive 8. So these answers are conjugates just like these factors are, okay? So I would set up my number line. Let's see, who's first would be the negative 8. And then over here, I'll put a positive 8. I know 0 is right in between, so I'm going to test my 0 again. True, I shade it. False, I don't. All right, so I'm going to use this one right here. I got x squared minus 64 is greater than 0. Or on this one, you could use the first one, x squared greater than 64. Either one of them will work. Actually, the first one looks easier, so I'll use it. So I got 0 squared has to be greater than 64. Well, 0 squared is 0. So 0 greater than 64 is false. So we don't shade where the 0 is located. So let's see, I had my negative 8 and my positive 8. I'm not going to shade where the 0 is, which means I'm going to shade those outsides. So since I shaded the outside, it's going to start at negative infinity. And I'm going along the number line until I hit -8. All right, there was not an equals under that, so we got to use parentheses. And then union it, parentheses. You skip the middle, so it picks back up at the +8. And then it goes until it hits positive infinity. So, main thing you got to watch out for on these is, am I using parentheses or am I using those brackets? Now, y'all, if you're weak on factoring, hit them on that quad and knock them out that way, okay? All right, let me see. I think there was, there's only 7 of these, and we're on what, the 5th one now? So 5, I got 81 minus x squared is less than or equal to 0. So first thing we'll do is put them in order. I'm going to put the x squared first, so it's a negative x squared plus the 81 is less than or equal to 0. Now, if y'all remember on factoring, we don't like the x squared term being negative, so I'm going to divide everybody by -1, and I'll write that here. Since x squared term is negative, we divide all parts by -1. And if you remember when y'all was factoring in your foundations class, if we had a negative out front, you factored it out like a greatest common factor. But when you're dealing with an equation, you just divide everybody by the -1 because it's not going to change to 0, right? 0 divided by -1 is still going to be a 0. But what you're doing is you're making the x squared term positive. The positive 81 now turns negative, and then that's going to be less than or equal to your 0. Now this will factor pretty quick. X squared is an x and an x. My last number is negative, so I got a positive and a negative. Now, since that middle is 0, this is perfect squares again. So to get my numbers, all I need to know is the square root of that 81. And let's see, the square root of 81 would be 9 and 9. All right, then you set them equal to 0 to get your signs changed. Sort of sad because you're making the positive 9 into a -9, and then the -9 you're making into a +9. All right, you got your 2 answers, so you're going to come over here. Let's see, first would be the -9, and then the 9 would be to the right. 0, once again, is in the middle. And that's what I'm doing here. I'm just drawing where my 0 would be located on this number line. Because we know the patterns, right? It either shades the middle or it's going to shade the outsides. So, y'all, you can use either one of these equations. So I'm going to use 81 minus 0 squared has to be less than or equal to 0. You could have used this one, x squared minus 81. Any of these equations, okay? Well, 0 squared is 0. 81 minus 0 is 81, less than or equal to 0. Well, that is false. So we don't shade where 0 is located. So I had -9 and 9. So 0 was in the middle. This became false, so I can't shade where the 0 is, which means I'm going to shade the outsides. All right, now writing this one in interval notation, you're going to start at -infinity until you hit -9. So, would y'all put a bracket or parentheses at that point?
Is it a bracket?
In a bracket, there you go. Was that a telling me or asking me?
Both, kind of a little bit both.
Okay, good job. And then your union from the +9 in the bracket until you hit positive infinity. All right, y'all, what's next? Number 6. So number 6, I got 2x minus 1 minus x squared is less than 0. So I'm definitely going to put this one in order. I'm going to put that -x squared first. Then I got a positive 2x. Then I got the -1 less than 0. And y'all know what I'm about to do next because I don't like that -x squared. So I'm going to divide everybody by -1. So I can get that x squared positive, and here you go. You get a positive x squared. The 2x was positive, it becomes negative. The 1 was negative, it becomes positive, and all that's less than 0. So all that -1 does is change signs when you divide by it, okay? All right, so now we're ready to factor this. X squared would be an x and an x. Last sign's positive, so both of these will be negative like the middle number. Oh, and y'all, we ain't got but one set of factors we can get out of that. That's a prime number. And the only way to get a 1 is a 1 times 1. So both of these are going to be 1s. And those 1s add to get a 2. So look here, I got a repeating answer. So all I'm going to do is solve one of these. I'm going to set x minus 1 equal to 0. I'm going to add 1 to both sides, and I get x equals a positive 1. So remember, anytime I got a single answer, that's the only number we're going to exclude from the domain. So we're going to exclude this number from the domain. So that means your domain will start at -infinity, goes until you hit the 1, and then you're going to union from the 1 to a positive infinity. Also notice this, when you get one answer, this is going to be parentheses only. It can't be equal to it, because then that means all the answers would have worked. So it makes a difference on that. So what happens on these when you're graphing them? When you got two answers, your parabola comes through and it crosses through the x-axis like this, and you get the two answers. When you get one answer like this, it's like the parabola comes down and touches the x-axis, but it don't go through it. So that you get the one answer here. Over here, you got the two answers, okay? All righty, so that would be my Remember, one answer is the only number you kick out of your domain. Everything else is going to look the same, okay? Except for that one number. All right, y'all, then we hit, the last one would be number 7. That is a x squared plus 16 is less than a 6x. So we definitely need a 0 over here, so we're going to have to subtract 6x from both sides. So that'll give me what? An x squared minus my 6x plus my 16 is less than 0. All right, so now we got to try to factor this. So x squared will be an x and an x. Last number's positive, so both of these will be negative. And then let me find my factors of 16 would be 1 and 16, 2 and 8, 4 times 4, and that's it. So since that's positive, I need factors of 16 that add to get 6. Well, these add to get 17. These add to get 10. These add to get 8. So you cannot factor this. So this does not factor. And y'all, since that does not factor, this is a no solution, which is a 0 with a line through it. All right, y'all, that was that section. So the biggest thing in 8.6 is being able to sort of factor those. Now, I will say this, if you try to work these problems, so I'm going to do this one on the quad real quick to show you. If you do this on the quad, you'd put in a 1, a negative 6, and then a positive 16. But notice when I'm getting imaginary numbers. We can't plot imaginary numbers on a number line. So that's why if you get imaginary answers or radical answers, this is a no solution, okay? In order to be able to work this, you got to be able to factor it with real numbers. All right, so let me look. I think that's the, yeah, that was the last material for test 3, okay? So let me stop this share. And then I'll stop this recording.